Greetings, the Astro 30 here, and today's video is sort of a different one. This is going to be a compilation over the next month or so. So by the time this is released, it'll probably be somewhere in the order of the end of April. Currently, what am I going to be doing? Well, what is this? You may be asking yourself. Well, if you don't already know what I'm doing by the title, I'm going to tell you. I'm going to be building, well, a bench desktop test amplifier where I can test CD players, tape decks, or whatever I want to do. Just hook a computer up to it to test for sound output, stuff like that. But in this box, I have, this is a toroidal transformer. Now this one is a 18018 at 1.4 amp per winding, so the overall current handling of this is close to 2.8 amps. So this is a 50 VA toroidal, and its rough measurement is around 80 millimeters in diameter. Now it comes with a mounting cup and two neoprene washers. One goes on the bottom between that and the chassis, one goes on top, and this goes on top of that, and then you pass a bolt through. Unfortunately, in this kit we have the mounting hardware, yes, but we're missing the M6 bolt. So I've contacted the seller, and who is in Australia, and he went and checked, and he opened another box, and yes, it had the bolt and nut in a separate plastic bag, which is not in this box. So he said, what did I want to do? I said, well, can you just send me the bolt and nut? And he said, yeah, sure. So I expect to get that sometime next week, or this week I should say. So that's the power transformer, which should be adequate enough for what I want, and I'll be using that transformer to power this module, this OCL power amplifier module. Now I have, however, ordered another one of these kits. They're only like no more than 10 bucks, because I'm not really happy about the damage I did to the board. I mean, the board still works, but I want to do it a little bit differently. And instead of using a heat transfer compound there, which is okay, I went and bought some TO3 isolator seal washers that don't require any thermal grease. So I'm going to use them in between the transistor and the heat sinks instead of the compound. I'm also going to use this any 5532 preamp. However, I've ordered a new kit of this because I want to mount the pots off the board, and I don't really want to have to sit here and desolder this one. This kit was about 7 bucks, so I've ordered a new one, plus I've ordered some 7815s and 7915 regulator ICs for it, and I'm also going to use this Clover Audio Clover Pro 5.5 speaker protector. But I'm going to make a slight modification to this as well, and you'll see later in the video as to what. And I'll also be using this input selector board and the switch that goes with it. So I've got to test to see if this actually works first. Now the only problem with this preamp is there's no input DC blocking capacitor, so between this and this I'm going to have to put a probably 1 microfarad MKT style capacitor just hanging off the input here, and then solder the wire, because there's a cable connector in here that goes from the board, which is stripped at one end but has a plug on the other, which is handy. I'll just open this bag. That's the audio feed lead, and as we can see it's stripped on the other end, so that makes it easier. I can just solder it straight to the board, but I'm going to have to put a capacitor in between both the hots, because there isn't one on the preamp. It wouldn't be that much of a problem, however you should really have an input capacitor. So that's the plan. I'm going to put all this stuff together in a case with a nice front panel label and build this amplifier, and I'm going to take you along with me. And one final thing on this OCL amplifier is I'm changing these 100 microfarad capacitors to 4700. I want the best filtration that this thing can possibly deliver, and I'm also going to upgrade these rectifier diodes from 1 amp ones to 3 amp ones. So when I get the new board, I'll get some new diodes. I've already ordered some caps, and yeah, I'm going to then just make that little modification, because the rough current draw at full power is around about 700 mA, 1.4 for both channels, so they're only 1 amp diodes. They're not going to do the job. Not that you'd be running it close to full power. So anyway, I got to test this. I've got to do a modification for this, and I'll explain that in just a second. Okay, speaking of that speaker protector module, now they have an LED that comes off of pin 6 of that IC that controls the relay driver. It goes through an LED, and the LED comes on when the relays come on. However, I want the LED to come on when it's in mute mode or first powered up. So this would be either a mute or a protect light. I want that to come on when the relays are off and go off when the relays come on. So basically I'm going to use an NPN inverter. You'll notice that this transistor, 2N3904 for instance, is forward biased here from the positive 12 volt rail that comes off of the positive 12 volt power supply of the module. When pin 6 is off, there's going to be no current flowing through here. So this transistor is going to be turned on via this resistor, allowing current to flow from the emitter up to the collector and turning the LED on. As soon as pin 6 becomes high in the negative, so it comes down to 0 volt potential, then it's going to reverse bias this transistor, and then current flow is going to stop because the transistor is off. So therefore the light goes out, and as soon as the relays drop out, the light will come back on. But it also gives you an indication when you first turn it on, the thing is in mute, and then when the light goes out, the amplifier is ready to produce sound. So I need to build this circuit up on a breadboard and connect it to pin 6 of that IC on that protector module, and just test that this works. I might have to do a little bit of massaging to the values here. That's the plan, so that's what I'm going to do right now before I do anything else. Okay, and a short time later I've got it breadboarded up. Now I've got it laid out as the circuit that I said I was going to build, with two 10Ks, one going to the positive and one coming off of pin 6. However, if I bring this down to negative, I'm using a 9 volt battery as a test. If I bring this down to negative, well, it's not going to do anything, mainly because these values are the same, so it's just acting as a voltage divider and probably causing that resistor to heat up. So if I now move this wire to the base, as we can see, if I can get it to stay on there, as we can see the light goes out. However, I don't want to connect the base directly to negative. I mean, I can. So what I might do is I might change this 10K resistor to say 1K, and now I will bring this to negative potential, and it still doesn't work. So I am going to forget about the resistor and connect it directly to the base, and that's the theory. Okay, I've carefully got the circuit hooked up how it should be connected. I've got it connected to a power supply now, so when I turn the load on, well, it's not doing what it's supposed to do. Both lights are on. Yeah, it doesn't work. Okay, I'm going to need to rethink this. Alright, I was almost right. Now it works properly. I had to use a PNP transistor as a switch, and I'll show you the circuit change in a minute. But it does work as expected and works the way I wanted it to, after blowing 2 blue LEDs in the process. But it's doing what it's supposed to do, which is showing me that the circuit is muted when the power is first applied, or, so I'm just going to put power across these 2 terminals like I did before to test the circuit. There we go. And that takes a little bit of a while to come back on, but that's working as expected. So this is the revised drawing. I'm using a 2N3906 instead, and basically the operation of pin 6 of that IC on that speaker protector is, it starts off at a low state, so technically it's applying a forward bias voltage to this PNP transistor, allowing current to flow through it, and then starts to go high. So when it starts going high, the base bias voltage is removed, therefore the LED goes out. And that's all I wanted to achieve, and it took me an hour and a half to do it, but I got there. So that's part 1 of that. I can just build that up on a piece of Vera board now that I know it works. Okay, moving on, I want to test this input switching board to see if it actually works. So I'm going to hook up the cables. The problem I might have with running this on the 18 volt transformer is that's a 25 volt rated cap. So that's a, if I could see what I was doing, that's 25 volt at 470 microfarad, I think it says. Yeah, 470 microfarad, so I'm going to have to change that to a 35 volt. There's also a 1000 microfarad 35 volt, that should be fine. So for testing purposes, I've lowered the voltage to 17 in, and it's not, yeah, it is using a 4-wave bridge rectifier, so it should just work. Well, you'd think so. There is no voltage coming up to this stupid circuit. Right, well there is there, and it goes away there. So I've got 11 volts there. Aha. Oh, they're blue LEDs anyway. Nice. I see. Now, the LEDs have to be in circuit because they're actually using it in series with the relays over here, or the driver circuit. So that's how it's limiting the voltage to the relay, by using it in a series pass circuit. Because that's why it wasn't working. So all the LEDs need to be in circuit. Yep, yep, and yep. Okay, so that's working as it should. All relays turned on in sequence, so I know that it's working. Thank God for that, otherwise this would have been a wasted day. So, I know that input circuit board works, but the LEDs have to be in circuit for it to work. It took me a while to figure that bit out. It helps if it had a schematic, you know, but it doesn't. So, and this module was pre-built. I didn't build this. So yeah, I'm going to have to change that to a 470 mic 35 volt, maybe even a 50 volt will fit in there, don't know. But yeah, that's one modification I'm going to have to make. So now I can move on with something else. Okay, and continuing on, I've got this box from Suntech International Limited. And this is actually a case and electronics enclosure. So let's open the box. Let's see what we've got here. Look how nicely it is packed with this foam stuff. And it's actually, I think this is actually upside down by the looks of things. So I'll take it out of the box. Yeah, it's upside down. So it's a fairly decent size. It's about 305 by, I think it's 78 high by 250 deep. That's in millimeters, and it's ventilated on the top and on the sides. Even smells brand new. That comes off. We have a bag of parts, which is 4 rubber feet, some bolts and nuts, but I don't see the screws that actually hold the thing together. So I think I just put in self-tappers. So I've got something that will fit that, but I'm a little bit disappointed that, well, in this bag of screws and stuff, it comes with 4 bolts and nuts for the rubber feet, but it doesn't actually come with the screws to secure the case, which is kind of annoying. So anyway, whilst I've got this bag out, I might as well put said rubber feet on. Right, now this is only rubber, so I don't really want to go over tightening it, because otherwise I'll pull the bolt straight through. It really needs a washer on there. I might change that round a little bit later. There goes the screwdriver, so that's tight enough. That'll stop it sliding around too much. Okay, well I suppose the ultimate question is everything going to fit inside this case? Well, yes. If I mount all the pots that are going on the front panel here in the centre, it'll clear that board just fine, and I've got plenty of room actually to bring this more further back here. It won't interfere with the transformer. In fact, both the power transformer and the power amplifier module will sit alongside each other towards the back even better. So yes, I've got room to put that. As for the preamp, I'll probably mount him down here somewhere, well away from the transformer obviously, so as not to induce any hum. And well, then we've just got the input selector, which will be mounted here. So I've got to leave room for that to mount. Probably have to bring the power amp forward a bit, because that's got to stand up yet. But the preamp can go right towards close to the front. But I've also got to leave room at the front here for this selector switch. So that also has to, because that's going to stick out quite a fair bit. So even if it was in the middle, and I use shorter standoffs on this obviously, yeah, that'll fit nicely, I reckon. Yeah, I'm happy with that. The final piece of the puzzle, which is the speaker protector. Now I can either mount it there, towards the front somewhere, or I can mount it at the back. I mean, this transformer can now come forward a lot more. And I can, you know, mount that across the back somewhere. That'd be perfectly fine like that too. So everything will fit. I'm debating replacing this circuit board with the updated version. Don't know yet. But there's plenty of room to mount it either way, really. I can mount it that way, or I could mount it up that way. It's really much of a muchness. And then I've got to leave room for the power cord obviously to come in, and the fuse. So if I mounted it there, that'd be fine. And I still have enough room next to it for the speaker terminals, just maybe. Yeah, I'd have to think about it a little bit more, but going on what I can see here, it's all going to fit just nicely. So if this power amp module was mounted almost close to central front and back, then yeah, everything will fit in there just fine. And the preamp can be off down there somewhere. Got me the case, which I've been waiting for, so, and it's actually a rough aluminium, so if I put a sticker over the front of this, a printed label, it will adhere better to it. And I'm actually, this time, as compared with that power supply, I might get some craft clear acrylic to spray on top of it so that it actually protects the paper and the toner a bit better. Yeah, everything's going to fit in there. Just got to watch the leads for the transformer here aren't going to go too close to the edge of the case, and as the edge is coming down, make contact with it. So obviously I would turn it around somewhere so the leads were facing at the back, which would be probably a good idea. And I'd have room down in here for a terminal block for the secondaries to connect to, so I can wire them up all to the individual boards that I need to do. I also got the replacement preamp today, so I'm not going to make a video on constructing that. You've already seen it, and if you haven't seen it, I'll put a link in the description of this video so you can go see the building up and the testing of that and the problems I encountered. So this one actually comes with potentiometer knobs, but I'm still going to replace the regulators with 15 volt ones. I am actually debating whether or not to still board mount it, the potentiometers I mean, and have them coming out the front panel at the bottom here, and then a selector over here, but that might look a bit weird. Still haven't decided. I'm probably going to use the knobs though, because they are quite snazzy, and I'm hoping I can actually find some more that are bigger than that are the same colour, that are push-on fit, that look roughly the same. If not, I'll just replace them all with the same type of knob from the same manufacturer, but just different sizes, because I want a really big one for the volume, because I like a big one. And I will at some point reverse engineer a schematic of the input selector so everyone can actually see how this thing actually works. So I'll do that over the course of the next couple of days. But yeah, look at this. They've only soldered the relevant pins, and they're not, well, that one's not even soldered properly. So yeah, it's not soldered in all the way, so it's just going to probably move around. So I'm going to resolder all these and solder the ones that aren't soldered, and probably reflow some of the joints on the selector board because they look a bit sus as well. So I'm just waiting on some other parts like some potentiometers and some decent filter capacitors to put over here for 700 microfarads at 35 volt. I've ordered about 10 of them. So when they come in, I can actually, and the power amp board, I can actually go about starting the assembly of this. The next step would be to design the front panel label and one for the back, so I know where I'm going, and then a rough drawing plan of where everything's going to mount in the chassis, and then we can build this thing up and test it. And just one last thing before I finish up this portion of the video, with this speaker protector with the LED I was going to modify so it would come on when the relays are off. Here's the original schematic I came up with one transistor, 2 resistors and the LED. I thought about it and thought, well, in the original circuit we've got pin 6 here that goes off to, well, your relay, and also to the cathode of an LED through a resistor up to the 12 volt rail, like that. What I thought is, well, why not forget about doing it that way, and why not just do this? It would achieve the same thing as that. So I'm just going to quickly test that theory, because if I can limit the amount of circuitry I have to do, I probably won't even need to use a piece of Vera board. I can just simply put a inline resistor on the LED with some heat shrink tubing on it onto the front panel, and, you know, make it simpler on myself. So let's find out. Okay, got it hooked up. Ignore all this other crap on the breadboard here. Light comes on, light goes out. So yes, it'll work exactly the same. So I just thought I would include that extra bit, even though I'd already shot the previous piece of video, just to prove that, well, I did think about it, and before I get any comments saying, oh, you could have put an LED in reverse polarity to pin 6 and then taken it down to earth instead of positive and it would have worked the same without the transistor, dude. Yes, I know. I thought about it, and it would be doing exactly the same thing, and it is. So, yeah. I might actually change this 1K resistor though to a 4K7 because it is a little bit bright. Alright, let's try that out. Oh yeah, it's a little bit more respectable, it's not as bright. So yeah, I'll go with 4K7. So actually a short time later in the mail, I did actually receive the bolt and nut set for that transformer. Unfortunately, it's just a standard hex head. Now, most of the toroidal transformers came with actually a screw head on it. So this sticks out a good 3-4 millimeter from the bottom of the chassis, so the feet want to be pretty high. But, well, at least I've got some way of mounting the transformer now. Okay, before continuing on, I thought it would be prudent to show a functional block diagram of how I'm going to wire the thing up. Now, we'll start over here. We've got the 240 volt primary coming in through a fuse. That fuse is yet to be determined. 1.5 amp should be enough. Through a power switch into the primary winding of the toroidal. Then the two 18 volt windings are joined in the center, going to the case earth there to form the 0 volt rail. And each secondary goes off to each module. We've got both secondaries going off to this module, both secondaries going to this module, only the first secondary going to the speaker protector and the input selector. Now, this is the input selector and the switch PCB with the inputs there. The left and right outputs are going into the NE5532 preamp. The left and right outputs of that are going into the OCL power amplifier, and the left and right outputs are then going into the speaker protector, then out to the speakers. Now each of these earths, by right, should all come back to a star ground. In other words, to a single point. But technically speaking, the power output grounds, because there is a ground here as well, the power output grounds should be separate from the signal path or signal input grounds, technically speaking. But you can actually all wire it to a star point. This is to prevent any earth hum loops, which will give you a hum in the output. So that is the reason why you would put it to a star point. There are other ways of dealing with hum on the output as well, but if that becomes a problem, we'll explore that later. But that's the plan. That's how this amplifier and all its modules are going to be wired together. I'll just get rid of this star demonstration thing here because it's not relevant to how the thing is wired at this point in time. So that's the plan, and that is the block diagram I've come up with, and that's what I'm going with. Right, well, I've spent most of the morning stuffing about and achieving nothing. It's like 1 o'clock in the afternoon now, but good news everybody! The new so-called 100 watt per channel, or 100 watt total, whatever, OCL amplifier has arrived. So I've got the new module to assemble, and the interesting thing about this one is it actually came with, well, a drawing of the overlay and how you connect the transformer. Everything's in Chinese, speakers and stuff, parts list, and voila, the schematic. And I'm not too sure what they're going on about here, but yeah, I think that's just telling you how you connect the speaker from the output across the actual where the filter caps are, or the filter caps earth. In other words, you return the speaker's earth to a star earth point like I just previously mentioned. Anyway, that's quite nice to see that they've actually included the schematic and some information with the new kit. The old one didn't come with one, so I'll hold on to that. Now that brings me to my next point. I have actually spent some time over the last couple of days designing the front panel and of course the rear panel. Now this is undrilled at the moment. It's just a normal self-adhesive sticker over the bare aluminium and it's got no protection on it yet. And if you'll notice, I've used the full width of the sticker, so it's got like a 5mm overhang on each end, which is okay because the edges of the top will actually cover that, and if you get it relatively central you won't even see the lines. But I need to protect the paper and printing before I start drilling, which brings me to that. This is what's known as cobathane, which is actually a polyurethane clear varnish really for doors, windows, trim and furniture, and it's about $13 a can, so it's pretty expensive. But the idea of this being polyurethane is it's supposed to be scratch resistant, so before I do any drilling what I want to do is spray this onto the front and back panels, and this will in theory harden the paper, make it adhere better to the metal because it can peel off, and when I actually go to drill the holes would lessen the risk of the paper actually tearing around the hole and making it look ugly. So that's my next job, and I'm not sure how long this stuff takes to dry, 24 hours I think. So what I'm going to do first is take the rubber feet back off because I don't want to get this stuff all over it. And I really want to put washers in between the screw and the foot because yeah, there's nothing there and it can easily rip through. So I'm going to take the feet off, take this outside and give it a coat of this cobathane or polyurethane, and yeah, we'll see how it looks. Alright, see how I go. Right, turn it around, do the same thing. Going about 15 centimetres away from the work. I'm just going gently up and down. Don't have to go too fussy with it. Now I'm probably going to have to give that 2 or 3 coats, so I'm going to leave it for a while out here in between coats, 20-30 minutes or something, and I'll come back and see if it's dry, and that would be just by touching the edge there just to see if it's sticky. If it's sticky then I'll leave it, but for now that means I can't really do much else except move on to something else. So I've also got some 4700 microfarad at 35 volt capacitors for that power amplifier module. This pack of 5. It's got 2 packs, so I've got 10. And I've also got some 50k logarithmic dual gang pots here, 16mm with the fluted shaft, flared shaft, what do you want to call that, ones that fit push-on knobs. This cost me, I can't remember offhand, about $20 I think, but there's like 10 of them in there, and it comes from taidaelectronics.com. So that was the only place I was able to find logarithmic pots with the knurled, I think is another word for it, shaft, 16mm panel mount and PCB mount. So that's for the volume control, and I've ordered 10, so I'll never need another one again. I'm also waiting on some 50k linear of the similar type of these from eBay. I think I ordered 10 of them as well, so I'm still waiting on them. I think I have 3 of them somewhere because I need one for bass, treble and mid-range respectively, so I could probably borrow them off of that SDK amplifier that I've used them on. They're all 50k linear, I think. So, and there's another one knocking about somewhere. So yeah, that's probably what I'll end up doing in the meantime. I'm also waiting on some really cool looking audio knobs from the UK. A 17mm one, there's 4 of them, and one 40mm large knob to put as a volume control. Hence why there's a big scale printed there, and I'm still waiting for this first coat to dry. It's still a tiny bit tacky. It's not looking too bad. It's soaking into the paper nicely. That's what I want to do, is I want it to soak into the paper, so it'll strengthen the paper a lot more, and stop the chances of it bubbling or getting damaged by UV rays, because paper being white will eventually go brown in sunlight. And this clear coat protectant varnish stuff is supposed to be UV resistant, so that's another great point to that can. So I'm trying to get it to stop it doing things like this. As you can see, the paper on this is starting to go all wrinkled, and over this end happened when I started drilling that large hole. So that made the whole thing look kind of tatty, but yeah, it's only a power supply. I mean, it's no real great loss. Eventually that's probably going to die and I'm going to build a new one. So that's so far what I've got. It's not much for around about 40 minutes of video, I know, but I hope you're enjoying this long video. It's probably the longest I've ever made. But I'm going to take this right through to the very end. So if the video ends up being 2 hours long, it ends up being 2 hours long. But I'm going to try and keep it down to an hour and a half. So yeah. Anyway, continuing on with the next bit. It's the next day, and the second to last piece of the puzzle has arrived. These are the knobs. So we've got one large 40mm diameter knob and 5 17mm diameter knobs. I only need 4 because I was actually going to put a balance control on the amplifier, but I decided against it after all that when I looked at the spacing requirements when I was designing it, so I left it out. But I've got a spare knob. They are push fit, so they have a fluted shaft or knurled shaft in the middle there, just plastic, well, nylon actually, and finished with an aluminium outer shell. Now these came from England, somewhere in the UK, I can't remember offhand where. But the biggest problem with this was it was $15 odd postage for the large knob and $15 odd postage for the smaller knobs, and I ordered them at the same time and they came at the same time, but that means, practically speaking, I have spent $30 alone in postage just for this, which is quite expensive. Considering the larger knob was about $4.95 Australian and each smaller one was about $3.95 Australian each. So that's a heck of a lot of postage. But you can't find these knobs in Australia anywhere, but it's they're quite nice. Now all I need is a pot to stick it on so I can demonstrate, but I don't have one on hand at the moment. Okay, so that's one of the 50k pots that I had left over from that SDK amplifier chip kit. So just make sure that it will. Yep, they push on. It's just a little bit stiff, but there you go. One volume knob. We're here. So, being nylon, you've got to be very careful when pushing it on and off the shaft to make sure it's lined up, otherwise you can actually damage it to the point where you might have to end up gluing it. But let's see what this knob looks like up against the front panel. Okay, this has had 2 coats of lacquer on it now and it's been sat overnight to dry, and it's nice and smooth and hard. Okay, so I'll get my knob. So I know my finger's in the way, but that is basically what it's going to look like up against the front panel. And I think the colour of that being golden sort of offsets the white just nicely. And we'll also have the same here for the function knob. So, and of course the bass, mid-range, and treble. And the skirt of the knob is slightly smaller than marking, but that's fine. I reckon that's going to look pretty snazzy. I'm excited. I am really, really ecstatic. So all I'm waiting on now is some of these 50k linear or 50k B pots with this type of shaft on it. They still haven't come yet, but they'll be here soon. And then I can actually start construction of the amplifier, and that's involving drilling the holes and mounting some hardware. I've got a couple of circuit boards to assemble and mount them in the case. So hopefully in the next shot that you see, I would have started drilling this case out and started mounting some stuff. Maybe not wired it up yet, but mounted it at least. And then have like the knobs all mounted on, so you can actually have a good visual here of what it's going to all look like, as well as the input and output sockets and the fuse holder and the AC inlet cable. So those cost me quite a lot of money. I could have probably come up with another alternative cheaper, but it wouldn't have the same look. And JCar don't actually sell knobs of this caliber or even that size that are push-on shaft fit. They have grub screws in them, which means I could have gone with normal pots with a flat shaft on them, but yeah, I wanted to be different as well as awkward at the same time. Anyway, moving on. Alright, got some progress here. I did actually notice I've made a mistake. That's the output connector there for the speakers, and you can see how close it is to this capacitor. I've actually changed this capacitor too on this selector board. As you can see, it's mounted in the case now to a 1000 microfarad at 35 volt. But when I was designing the panel, I forgot to leave room for the board that stuck out that way. But yeah, so rather than move the holes, I decided, well, I'll just put heat shrink tubing on it and just bend it up through the hole and just, you know, over the top of the capacitor. It won't hurt it. I mean, yeah. But anyway, I've got it hooked up to the power supply, the input module. I'm just checking the operation of these LEDs. See, now we're on CD, video, tuner, and auxiliary, and we can see that they're all lighting up. And you can hear the relays clicking. Yeah, so this is the back panel. It's drilling it was a little bit, yeah, how you doing? I've got to file out that hole yet for the power cord to go in. I've got the fuse holder mounted. As you can see, I've got the power switch, the sexy one on the front panel. Doesn't do anything yet. Got the protect LED. Now all LEDs I have mounted in LED clips because it just makes it easier that way. But I know that input board selector is working, so now I can move on to, I guess, working out where I'm going to put everything in the bottom of the case. That's sort of the idea I've got. I'm using the unpopulated PCBs for the preamp and the power amp respectively, just so I can lay it in the bottom of the case. That way, well, I don't have to measure anything. I can just draw around the holes I've got to drill out, same as a transformer, and yeah, that'll make it a lot easier. So there's just enough room in there for both and the transformer. So all I do is just, I might bring this transformer further towards the front. Now I'm going to have to mount the PCB, the power amplifier, around 180 degrees the other way because, well, the power input's on this side. So I'm going to want to put it as close as possible. Anyhow, I'm just going to mark out those holes, drill them, and yeah, come right back. Okay, that's the holes drilled. Unfortunately, this bolt, which is for the transformer, isn't long enough, so I can't mount the transformer today. I'm going to have to go out tomorrow and get another bolt, because it just happens to be Good Friday, therefore nothing is open. I am annoyed. Okay, if you're going to supply me with a bolt, supply me with the right frickin' one. God, that pisses me off. Anyway, the holes are all drilled now, so all I've got to do is file out the hole here to fit the plug in, and yeah, I can then start construction on the other PCBs. Now, there is going to be a problem. These 1000s that I'm changing to 4700, I'm not going to be able to fit to here, I don't think, because the heatsink will be in the way. Yeah, see, it barely fits there. I will never fit capacitors there, so I'm going to leave them empty. 4700, both sides should be enough. The only difference is really the lead spacing is different on the board. It's 5mm pitch, where this is 7.5, so yeah, it's going to be slightly wonky looking, but it'll do the job, and once it's in a case it doesn't really matter, right? Okay, power cord is in and in a strain relief clamp, so it's all coming together nicely. So the next step would be to build the PCBs, the power amplifier and the preamplifier respectively, which will take me a couple of hours to do, and then I can actually go about mounting things in the case. Of course, I'm still going to have to go out tomorrow and get another bolt for the toroidal, but anyway, it's coming on. Okay, I'm sitting here soldering resistors, and I thought about something here. I'm negating the bridge rectifier over here on the preamp, so it's now going to be DC in rather than AC in, and I'm going to run the DC in from out of the power amp, and I'm going to use those spare cap holes to give me the positive and negative points to poke the wires through the board and solder them to it. And the reason for that is because, well, there's only 1000 microfarad here and here as filtration for the AC, which is not really enough. Well, even though the regulators will take out most of the hum and ripple, but that means that the regulators will be working harder than they need to. So I'm going to have 4 T700 microfarad ahead of it. Negative is now up here near the screw hole, and positive's down here, and ground is still in the middle. So I've got to remember that the negative is at the top of the board. I will mark it with something when I'm finished. But yeah, that's my plan, using the filter caps up at the power amp to power this, and then regulate it down, and then give the 15 plus minus voltages for the op amps. Anyway, continuing on. Well, that's the preamp built, apart from putting on the wires for the potentiometers, which I'll do at a later stage. At the moment, I think I've had enough for today. But the interesting thing about these diodes that they supplied with it is, and I'm not sure even why, but these are RL207, which is a 1000 volt 2 ampere diode. Why the hell would you need a 2 amp diode on something that's only going to draw about no more than 20 mA? Okay, but however, I need to change the diodes in the power amplifier from the 1N407s, I think they are, 401s, if I can find them, 407s. Yep, so they're only 600 volt, I think 1 amp diodes, which is not going to be enough. So I can use these 4 RL207 diodes in place of it, and that'll give me at least 2 amps, which is going to be more than enough, because it's 700 mA for full power output on either board, and either channel I should say, and well, I'm not going to be driving that hard anyway, but yeah, 2 amps should be more than enough. 3 amp would be better, but that means I would have to enlarge the holes to 1.5mm because they won't fit otherwise. Anyway, that's the preamp done. The next thing to assemble is the power amp and then wire the wires for the preamplifier, the knobs. I haven't put the input connector on here yet because, well, I need to put a capacitor in series with the input wires, because there's no input capacitor on here, so I've left it off for now, because I may just solder wires directly to it, because I've got that other cable that goes with the selector that unplugs anyway, so it doesn't matter if it's hardwired in. I've also marked that top terminal there with a black mark, and so I know it's negative. So yes, it's coming together. Ha ha ha. Alright, the preamp is in. I've wired all the wires on. That took me about an hour. That's the selector cable. I don't know what he's doing out there. I've got the two capacitors, 1 microfarad, 50 volts here at the input. Input taken on the positive, negative going to the preamp. Doesn't really matter. And then that goes into this audio, well, not audio cable, but this cable, which then is plugged into the output of the selector board. I've also got the knobs on. I must have measured these incorrectly, because when I drilled it, there's an 8mm hole. The shaft is supposed to take a 7mm hole. So when I put it in the locator, it's actually pulled it over a little, so you can sort of see that they're not quite on center. The other thing was that this knob came out about that far from the panel, so I had to do something funky. I stuck another pot nut on the other side of it, which is now negating the locator pin, but that's alright because that was off center that way as well, and it looked way off. So, and it does stick out still a little bit, but so does that one, so I've just pulled these ones out a little bit to compensate. So now I'm ready to hook up power to the preamp and test it to make sure it's actually working. Connecting fly leads here. Now negative is over here, positive is down over here. I have marked a black mark on the terminal, so all I've got to do is connect some fly leads, hook up a power supply and an oscilloscope to the output. Okay, got it hooked up to the power supply, the correct array around, and this has got a bridge rectifier on this input selector board, so it doesn't matter which way around the cables are. I've just taken from the negative supply, doesn't really matter. Set at about 17.8 volts, so I'm about to turn the load on and see what the output on the oscilloscope is doing. So I'm currently set at 5 volts per division. Well, you won't see anything with the volume control down. I see absolutely nothing on the scope, and I've turned the volume up, so I'll just touch one of these leads. I have absolutely no output. Well, that's interesting. Oh, there is. I can see there is actually a output there. Okay, I suppose I should hook up a signal generator and see what the difference is. Okay, I got the signal generator hooked up with 1 volt input. I'm only getting not even a volt back here. Oh, it helps if I turn the volume up. Right, yes, I'll change that back to 5 volts per division. That looks a little bit more healthy. Yeah, we're currently at 9.53 volt peak to peak with a 1 volt input, and we've got a nice clean sine wave. Very nice clean sine wave. So that's increasing the treble. That's decreasing the treble. So that's back at center. This is increasing the mid-range, and you can see because it's 1 kilohertz, this is where roughly the center frequency of the mid-range control is. So you can see that that's affecting it quite significantly. So let's try the bass. Bass you won't see much because its center frequency would be a lot lower, probably 500 hertz. So I'm going to change the frequency to about 160 Hertz. So still at 1 volt. As you can see, the sine wave stretched out a lot more, and now you can see that the bass control is actually having an effect on that particular signal because it's of a bass frequency. Okay, mid you'll still see some, but you won't see much with the treble, except it just gets noisy. Okay, so let's change the frequency again. This time I might select where the treble would be, which is probably 12,000 Hertz. So we're now at 12 kilohertz, and it's better. So treble, yeah, you can see there's a significant. Yeah, so that's exactly how the tone control network should work. Mids having little to no effect on the signal, probably about a volt difference side to side. So I know that the preamplifier is working and outputting quite a significant voltage. It's at 3.40 volt RMS and still 9.9 peak to peak, so almost 10 volt. So that's a significant difference compared to the other preamp. And I'm running on 12 volt, 15 volt regulators, and they're not even getting hot. So next I'm going to change the mode to sweep, and we're going to look at the frequency response with all the tone controls at their flat or center position, and just see if we get a relatively flat response. Looks very reasonably flat. Don't see much change in the output voltage. It's still around about 9.8. So yeah, its frequency response is pretty flat from 20 Hertz to 20 kilohertz. Maybe slightly starting to shrink. Not by much, but it is a relatively flat response. So yeah, that preamp is working perfectly. I know this video is getting long and boring, but now I'm going to change inputs and see if all the inputs are working properly. So I'll just move the... I don't have to test both channels, I know both channels are working. Yep, so that's input 2. Input 3. And input 4. So I just tested the left hand side as well to make sure that I was getting the same results in output, and also that all the inputs on the input selector here on the left hand side were working, and they all are. So I think this deserves a celebratory drink. Cheers. I think that's me done for today. So tomorrow's little exercise will be, well, assembling the power amp so we can actually drive some speakers, and finish the hardware assembly off inside the case here by mounting the power amp and the transformer, and then doing all the wiring for the mains. Pretty much everything else is already wired apart from the output of the preamp to the input of the power amp, and the output of the power amp to the speaker protector through to, well, the output leads, they're still loose, you see. So that's going to be the plan. I reckon it'll take me probably an hour and a half to build the power amp, probably maybe 2.5 hours to mount and wire, and then we can do some proper tests on that power amp and actually get what its real output power is in watts, because I was using the Vmax figure, the first one here, when I was calculating that, which is incorrect. I should have been using the peak to peak value or even the RMS value, but the peak to peak value definitely, and then yeah, well, I would halve that, then I would square it, and then I would divide it by the load, and that will give us our output power. So yeah, she's coming on. I'm quite happy. The volume control works logarithmically as it should. As you can see, it's slowly coming up. Now it's up full. So yeah, I'm happy. And now just another quick note before I move on. This is why it's imperative to have a signal generator and an oscilloscope, because you can actually see what audio electronics is doing and how much output voltage you're getting, etc. It's very handy. Also, I noticed there's a difference with this preamp compared to the last one I built. The last one had a little IC style bridge rectifier. This one uses discrete diodes instead. This board is marked version 2, and well, they've marked the mid control on the old version, which I think is version 1. They marked it as alto, as they did in the instructions and stuff, but on this one they've marked it mid. Maybe because alto was confusing to some people as to what it actually did. But yeah, those are the two differences I've noticed, plus these two ICs are closer together physically than they were in the other version. And they changed these headers over here. They used to have a 3-pin here for the input and 4-pin here for the output. Now they've just got 3-pin, 3-pin, and in the kit they actually did supply the headers, but of course it's headers of this type of style which I cannot get plugs for, so I'm not going to use them. JCar don't sell that type of header plug, so it's not going to happen. So yeah, so tomorrow we may get some power to this. Woohoo! Alright, it's the next day and I've got some progress. I have the power amplifier module built and mounted in the case. I've also got the transformer mounted with a longer bolt. That's probably a little bit too long. I've wired up the protect LED to the back of the circuit board of the speaker protector. There's the wires going in there. And I'm about to do two tests. One, I'm going to test the operation of the LED on the front here. And two, I'm going to test with DC voltage the power amplifier and bring it up slowly in voltage. Look for some smoke, you know. Power on self smoke test and all that. Got the power supply set to roughly what the DC voltage after rectification is going to be of the 18 volt secondary of the transformer. Just going to turn the load on. LED lights up. LED lights goes out. So that is functioning. Okay, next test. Now I've got the power supply hooked up to the DC wires to the power amplifier, which is going to be going to the 15 volt regulators on the power on the preamp, and so I'm just going to turn the load on. It's currently set at 0, and I'm going to watch for smoke as I slowly wind it up, and also keep an eye on the current. So if I move my hand out the way of the camera, right, we're at 1 volt. Nothing seems to be happening. Output stage is still cold. Oh, there was a little bit of current draw there for a second for 20 milliamps and then it went away. Right, we're at 5 volt, just making sure those two cables aren't shorting on anything. The output stage is still cold. We're now at 8, 9, 10. I'm going to leave it there for a second. Still cold, because now I'm going to measure for any DC offset on the output. Hopefully you can see that. So just going to measure the right hand channel. We've got no DC. Going to measure the left hand channel, which I had problem with the other kit. No DC. Okay, so everything's running fine as it should. So let's crank the voltage up to its full supply voltage. Alright, so I'm going to go to 20 volt. Nothing happening. Don't want to go too fast here because I might exceed it. 23 is about close enough. The output stage is still cold, so I'm going to reconfirm the DC offset, and then I might hook up a oscilloscope. Alright, so after reconfirming what the output voltage is on both channels, it's around 70 millivolts, so that's perfectly fine. So now I need to hook up an oscilloscope to each channel's output, and well, I've got to take the power amp board back out because, well, I forgot to solder in the leads for the audio input. Oh well. But anyway, I'm just going to test with a blurt test by touching each input capacitor here, because they're electrolytic. Just touching the metal cam to see if we actually get a blurt on the screen. Okay, got a dummy load hooked up. Power is back off, so I'll turn it back on. A little bit of a jump there. Touch one of these capacitors. There we go. I can see that that channel is operating as an amplifier, so I'll swap the channels around now. Okay, they're swapped. And that channel is working as an amplifier, so I know full well that both channels are now functioning. So, well, at least with the blurt test, I love that technical term, so I can temporarily disconnect my oscilloscope now, because I won't be needing it for a good while. So what I need to do now is complete wiring, and then I can do the full-on test. I think I finished with the power supply now. Okay, so what I need to do now is I need to remove the power amplifier back out of its home, so I can wire the input connector, which I need, which I'm only going to just use some of this ribbon cable for that. You should really use audio cable, but because of the short distance it's going, you shouldn't need to. And the issue with grounding, now my ground point is over here. There's another one over the back there for the mains earth, but this is going to be the star earth, as I talked about previously. Now, the center taps of the transformer are going to go straight to that point. Then one wire is going to go off to the power amp's power input center tap. The speaker leads are going to go to there. The preamp's center tap, or 0 volt, is going to go to there as well. Which means you only need to run ground, or the center 0, from this connector point up the cable to the connector, but you don't actually need to connect the earth pin at this point because it's already earthed over here. That'll create an earth loop if I do that. So, having said that, as long as you've got a conductor with earth coming up it, it shouldn't pick up any noise. Now if it does, well, I've got 2 of them, so I can always change the connector to proper audio cable if I so need to. I don't think it's going to be a problem because, well, I'm not picking up any noise on this cable, which is basically the same idea. So yeah, that's what I'm going to do now, is complete all the wiring and get this ready for a final test. Okay, about 3 hours later it's all wired up. I have isolated the main circuit boards from earth, and I've not connected the secondaries to the power amplifier yet because I have to test that this transformer is actually working correctly before applying power to the rest of it and blowing something up. Now whenever testing a unknown transformer, always check your continuity at the power plug. It should be a fairly high impedance. It shouldn't be any lower than 10 ohm. Okay, so I'm going to turn the power switch on so I've got continuity through to the primary of the transformer, and I'm just going to measure across the plug here. As you can see, it's a fairly high impedance. We've got 46 odd ohm there, so that's safe to plug into the wall on the primary side anyhow. However, I need to do a voltage measurement across these 2 secondary wires, and the actual impedance across this is fairly low. It's about 2 ohm. So it's not a dead short, no. Is it a concern? Well, yes and no. But just to be safe than sorry, I'm going to hook up the multimeter in volt AC, and I'm going to see what the output voltage of that transformer is when I turn it on. Now you want to be very careful when doing this because this is live AC, so if you're doing something similar at home and following along with what I'm doing here, you're doing so at your own risk. Just remember basic electrical safety. Always use one hand and do not put the other hand against the chassis or anything else, and you should be fine. So when I hit this main switch, we should have around about 36 volts AC there, or thereabouts. And we have 41. So yeah, that's pretty good. That means we're getting roughly 20 volt per winding. So that would equate to around about 27 volts DC. So that's, say, 20.5 times 1.4 RMS. I was close, 28.7. So it's still not exceeding the capacitor ratings in any way. They're rated at 35 volt. You want to stay within 5 volt of its maximum rating. So that's perfectly fine. So now I can just hook up the wires again to where they go and turn it on and see if it powers up for the first time. But before I do that, unplug it first. Okay, everything is hooked up again, so this is the moment of truth to see whether or not it's going to power up properly or go bang. Hopefully not the latter. So I plug it back in, and I'm going to stand over here when I do this. Always a bit nervous. I shouldn't be nervous, I'm pretty confident. Here we go. And bingo, we've got power. Everything seems to be working okay. So I'm just going to make sure I'm not exceeding those caps ratings. Now they're rated at 50 volts, so they should be fine. The cap on there is rated at 35 volts, so is the other one. That should be fine. These large filters are rated at 35 volt. That should be fine. So I'll just do a heat check. Nothing's happening there. That's good. I haven't connected up the speaker output yet. I'll do that shortly. I just wanted to get the preliminary power on test done to make sure that it's all working fine, and it appears to be so. Okay, so I'm just going to do another DC offset at the output check just to make sure everything's still okay. We have 81 millivolts there, that's perfectly fine, and roughly the same on the other channel. So I know that this is going to be safe to hook up to some speakers, and also be safe to hook up to a dummy load. So I guess the next thing to do would be to wire the speakers up to the speaker protector. Now, I don't know how well you can see it. That brownish thing down there, that round thing, that is a PTC or poly switch. It's basically a resettable fuse. When the current draw across it is greater than 1.36 amp in this case, the impedance will change and go high, effectively removing the current draw. In this case I'm using it for a poor man's short circuit protection. I have to wire the speaker connectors up to the speaker output of the power amp to those two poly switches, and then the signal should be coming through the relays out through the speaker jack. That scared the shit out of me. That capacitor just blew. I just realised that's a 25 volt capacitor, not a 35 volt. Christ, I could hear something sizzling and all of a sudden bang right in my face. I've also got another problem. The speaker protector is seeing 7 volt DC at the output, or the input, when there's only 75 millivolt coming out of that. So I'm confused at the moment as to what's going on, but I'm going to have to disconnect that preamp and fix that. And oh Christ. Okay, got the new capacitors in, everything's wired back up. I've removed the speaker protector because it wasn't working, And also, for some unknown reason, that bridge rectifier was starting to make a buzzing noise and then all of a sudden let out the magic smoke. So that no longer works now. Don't know what else it's taken out, but as it wasn't really working properly, for some unknown reason, I don't know why, I've taken it out. And I've just cut the leads to the LED off. There's now a protect light on the front that does nothing. But oh well. Wasn't exactly how I wanted things to go, but that's what happens. So now I've wired the outputs directly to the speaker outs here through the PTCs, so that should give me some short circuit protection. Now I'm almost ready to power it on for the first time and see if it's going to work. I've tested the preamp again by applying DC to it, and I have positive and minus 15 volt at each pin of 8 and 4 of each IC respectively, so I know that there is voltage getting there and nothing else is blown up. The regulators are fine. Okay, time for a test. So this is the reason why you don't overvolt a capacitor, because they explode, and considering my face was right near it when it happened, I got the shock of my life. Okay, got the multimeter hooked up across the output of the right channel. Am I scared to turn this on? Just a little. It's fine. We got 80 millivolt there on the right hand channel. Now I'll repeat the process for the left channel. $80 millivolts. Perfect. Alright, hopefully nothing else will go bang today. Okay, nothing weird on the output. I've got the ×10 probe on there, and there's an audio cable over here, so I'll just increase the volume a little bit. I'm testing the right channel, or the left channel. Yep, I can see the output. So I know that that one is working, but it's not very large in signal, so I'll put that back to ×1. That's a little bit more responsive. Even touching the transistors makes it make a noise. Okay. Right, so now I'm going to connect up a signal generator. Well, it appears to be working. I'm not at its max power yet, so I'll just keep increasing until it clips. There it goes. I'll say about there. We've got a V peak to peak of 33.6 volts. Okay, so 33.6 divided by 2 equals 16.8. Square that. Equals that divided by the load, which is 8 ohms. That's actually a little bit more considerable than it was before. It's 35.2 watts. So each channel is capable of delivering 35.2 watts. So there you go. But it's still nowhere near the mythical 100 watt. Because if it was 100 watt stereo, that would be with both channels driven to equal 100 watt. That at the moment, if we times that by 2, we're only looking at about 70 watts. Yeah, so it's 30 off of the mythical 100, but yeah, it's close enough. So it would be pretty decent loud, put it that way. So now I've just changed channels over to the left. I'm going to test the left output now, make sure that that's still giving me roughly the same output voltage. Because I don't want to run it for too long in clipping. That was actually clipping a lot earlier, about 30 volt. So, okay. So let's do that calculation again at 30.8 volt. So 30.8 divided by 2 equals 15.4. It's only going to be a little bit less. Square that, or equals that divided by the load, 29. So it's between 29 and 35 watt. There could be differences in circuit tolerances. Okay, what's the RMS output? Okay, so we know the output wattage is roughly 30 watts. We're looking at 10.95 volt RMS. So 10.95. I believe you can just do that and then square that, because it's already in RMS, equals that divided by the load. You're looking at 14 watts, roughly 15 watts RMS. So 30 watts peak and 15 watts RMS. Very, very, very good. Okay, so, alright. Next test is to hook up some speakers and see what it sounds like with sound coming out of it. Right, well I've got the top on the amplifier now. It's not screwed on because I don't have the screws for it, but it actually looks quite nice with the lid on top of it. And the vase just come up. Okay, so I'm going to turn it on and I'm going to listen to see if there's any noise coming out the speaker, like pop or unusual noise. There is a hum. Okay. There is a slight hum coming out of it, which I'll have to address. I've probably got an earth loop somewhere. Or it could be the transformer is just so close to the power amp it's inducing into it. So anyway. Okay, it's not coming out evenly out of both speakers either. Oh, it is now. Driving a bit too hard. That song is so annoying. Let's see if I can find something else. Okay, one thing I haven't tried yet is to see what happens when I change input channels, whether I get any noises like clicks and pops. No. 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 And all inputs are free of noise. There's a slight hum in the background. Don't know if you can hear it. But it's not loud and it's not annoying. So I'm quite pleased at how that turned out. Yeah, it seems to be driving speakers pretty well. I'm a bit annoyed about that speaker protector because, don't know where that came from. The bridge rectifier just shit itself on it, and for some reason there was 7 volts at the input of this resistor, which is connected directly in line here somewhere, and I couldn't figure out why. It's just unknown to me. I've looked at the schematic and I can't see how. I mean, at the other end of the resistor was the power amp's output, and that was putting out 78 millivolt or something. So I couldn't figure it out. And the actual input DC offset to this IC with this resistor configuration should be around about 1.5 volt. So that is the minimum that can be put into it before it goes into protect. So I don't know what the hell happened to this, but the reason why the bridge rectifier probably popped was because it was drawing shitloads of current through it for some reason, hence why there was 7 volts at the input. I don't know. Strange. So anyway, I hope you enjoyed this epic journey, if you want to call it that. I'm quite pleased with the results. So I'm going to turn it off and see what noise it makes. None. So I'll let the fill caps discharge. I've connected the LED of this switch across the power amplifier's LED position, and I changed that 20k resistor to a 6k 8 instead. I just did a little bit of Ohm's law calculation for what resistor value I needed for the 2 mA draw of that and 12 volts. Okay, so now I'm going to turn it back on. Okay, there is a slight thump there. Not much I can do about it. Speaker protector doesn't work. So anyway, I'm going to leave that run for a while, and yeah, I'm going to end this video now, and I hope you enjoyed it. Thank you for watching, and I might make another one like this soon. Alright, see you around again real soon. I'm the Astro 30, and as always, if you like this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyways, this is the Astro 30 saying, see ya, have a great day, and I'm not your Darlington.